Yeah, hi students. So the series of learning with respect to the factory simulation laboratory. So now we are going to see about the next exercise. The next exercise is exercise number 4, modeling and simulation of robot material handling device. And the subclass is going to be product variant. So before we get into the software, let us know what is this product variant and how this particular task is going to be done. So the main objective of this particular exercise is we are going to simulate a manufacturing workstation where the robot is going to interact with a machine and material flow equipments in such a way that the input geometry and output geometry will be entirely varied. So how to understand this? See, we have got a machine. The input geometry will be something else. The output geometry will be definitely lower than that of the input. For example, we are having let us take an example. We are having a cylinder to be machined. The diameter is a dia 50 and length is 100. And we are going to remove certain amount of material. Obviously, the output is going to be lesser than that of the input. So this is what we call as product variant. Now, with respect to it, let us learn how to do such realistic simulation in visual components. But here, for better understanding, what we are going to do is not have the same geometry. Let us have a different geometry. So let us kickstart with the process. So the block diagram here is first let us bring a machine, say FTC 350 category machine, a CNC machine. Then we'll have conveyor 1 as well as conveyor 2. Then we'll go for the two conveyor process, and from conveyor process that is nothing but conveyor 1 will act as the source and conveyor 2 will act as the destination for the flow of components, and it is going to be taken care by a generic articulated robot. And we knew the concept that whenever we go for any resources in visual components, obviously we are supposed to have a controller. So here a robot transport controller will be attached with the robot in order to ensure its effective functionality. Now, the main crucial aspect here is the input geometry. So the input geometry in this particular case, it will be a cube. So we'll provide a cube in this particular case, that is cube will be getting into the surface for machining into the machine, and the output will be a cylinder. So now let us learn how to go ahead with this particular aspect in visual components.
We'll load visual components now. So the software takes a while. The plugins are getting loaded. So wait. Yeah, the software has opened. So we'll check for the layout and we'll go for the e-catalog. From the e-catalog, we'll just get the lathe FTC 350 and we'll position a little bit back. Again, from the search, we'll get a conveyor. We'll position the conveyor onto the floor and we'll place adjacent to the machine on the left side. So once the position is over, rather than bringing a new one, we'll clone it up. We'll detach and position it somewhere on the right side of the machine. Now we'll go for the next. We'll bring the feeder. We'll bring the feeder and position it in front of the conveyor 1. That is, we'll go for the plug and play mechanism. Yeah, it got fixed to the interface to the first conveyor. Now the next step is we'll go to visual components and we'll get the other required accessories, that is robot transport controller, and we'll bring to the mid of the all the three entities. Then we'll bring up the generic articulated robot and we'll PNP to the controller. And obviously we need to have the end effector. So we'll go for robot tools. We'll bring the 3-jaw generic gripper and we'll P&P to it. So now the basic layout is ready. Now we'll bring the other things. We'll bring the other things, that is from conveyor to conveyor to conveyor, and we'll bring the to conveyor and we'll position it. Now, upon simulation, it is understood that the component comes and it stagnates there, and we can see the output editor that the flow sequence is lost. So now we'll complete the process. We'll reset it. We'll go to the process and flow where the labels are getting highlighted. We'll pick the from point, then the robot point, then the machine point, then it goes to the to conveyor point. So now the link, transport link has been established. So once the link is established, we'll go for the simulation. We'll increase the simulation speed little bit. So the robot picks up, loads the workpiece on the machine, it gets machined up, and now upon machining, the component is taken out and it is kept onto the secondary conveyor. So with this, the cycle is over. So now the main objective here is to change the geometry. Now before that, we'll go to the feeder. We'll increase the time interval, say somewhere to 30 seconds from 5 seconds. And now we need to work upon the geometry. So the objective here is the input is supposed to be a different geometry. So for that, we'll come back to eCatalog. We'll go to the basic shapes. So within which we can see there is one shape by name block geometry. So it is a block geometry where you have got a cube which is white in color. Pick and place it onto the floor space. And now the task is this has to be assigned to the feeder. So for that we'll go to product flow editor, and within which we can see visual components underscore cylinder is there. So it has got a default geometry of a cylinder. So that will change. We'll select it. The properties tab we have got on the right side, select the 3D brick geometry. Now pick the cube. So now the default geometry got changed, and you can see the component URL name also got changed. And in the properties there are dimensions are there for a cylinder, that will delete it off. Now the default has been changed and the dimensions have been deleted. Now we'll add the new property. So template property for the geometry. Now we'll change the size from default 400 mm to 100 mm. We'll change to 100 for all the sides. And now the important task is we need to ensure it has got. That is, the geometry has changed. Now we'll simulate it. And before that, we'll go for the next geometry. So we'll bring the output geometry, that is the cylinder. Again, we'll come to product type editor. Add on the flow group 1, we'll add a new product type. So click flow group 1, right click, add product type, and first we'll select the geometry. It is a cylinder, and let us change the type name. The name is changed as cylinder. So the name has been changed as cylinder, and now the dimensions. So nothing is there. So now we'll add the component template property and we'll give the dimensions. So we'll specify the minimum, that is radius and the height. We'll change the radius, we'll change the height, of course. So now we have did two geometries. We just brought two geometries. One has been fed to the cylinder and the other is idle. So now we'll go to the process. The moment we click the process, we get the label tag. On the product executor, whenever we simulate, you can see a green tab is going to appear. On the right, you can see a green tab. Now we'll simulate, and you can see that green tab button like thing is appearing on the end of the statement. That means the work what it is doing, the machine what it is doing. So after the completion, the button migrates to the next statement. So that's how it goes on. Now the geometry changed and the same input and same output is coming. But the target here is we wanted to have something different. That is output to be different. So where the change of occurrence occurs here is, it is with respect to the machine. So now we'll stop it. We'll go to the custom machine process to change the geometry. On the top grid, we'll include a statement called as change type. Process statement change type. So you can see a new type has come, and we'll go to the statement properties. New type is the cylinder, second cylinder what we have chosen. So now we'll simulate it. So input is a cube from the feeder. It is loaded inside the machine. And we'll switch it off the label, and you can see the output is a cylinder. So it is as easy as this. So input is a cylinder. You can see close-up view of that from the glass of the machine panel. So the output is a cylinder. So with this, the given objective is met. We have completed met the given objective, that is product variance. Input geometry and output geometries are not the same. So you can see that status button too. So now we'll stop. We'll go for our routine procedure, that is the creation of drawing. We'll go to the drawing menu, load the template, A3 size template, import it to the canvas, and we'll go for some random view. Let me go for a random view, but of course I don't think so. Front will solve the purpose. So delete, we'll go for the top view. We'll change the scale appropriately. Still it is not good. I think now it has almost filled the sheet. So therefore 1:25 scale has been chosen. We'll create the bill of materials. Create. So we get the data. So now we'll go to the drawing, select full preview, change the printer to PDF, then change the paper size as A4 and print. Yes, that's how we get the PDF out of it. So PDF is ready. So the exercise is done. Now we'll save the file. We'll save the file in the requisite location, of course in our Z drive. We'll browse it up, go to the file location, and somewhere we'll save it. I save it as SFL exercise 4. So now we'll see the PDF, how the PDF looks. So this is the final PDF. So thank you.